morning, students. I'm Chaitanya, Assistant Professor in Mathematics, working in Institute of Aeronautical Engineering located at Dundigal, Hyderabad. A warm welcome to you to the lecture on Gaussian distribution, the part 2. And it is a part of second module of the course curriculum, probability, modeling and reasoning. So today, in the last class, we have seen the Gaussian distribution, the perspective of theory. That is, we have discussed the theorems and properties related to Gaussian distribution and normal curve. Now, today we are going to see some problematic applications of Gaussian distribution. So, let us move to the lecture without any delay. So, these things we discussed. Of course, this is the density function of Gaussian distribution or normal distribution, which we have seen in the last class. And mean is always mu and variance is always sigma square for a normal distribution. And generally, we represent a normal distribution with the help of n mu comma 6 sigma square. Right. And also, we have seen the graph of a normal curve. The graph of a normal curve will be like a reverse bell shaped, centered at mu, which is equally stretching on both sides, that is perfectly symmetric and mesochotic. And these boundaries will cover 68%. These boundaries will cover 95% of area, and these boundaries will cover 99%. And always for a normal distribution, mean is equal to median is equal to mode. Also, we have seen that this is asymptotic. It seems to touch the x-axis, but it never touches x-axis. And also, these 2 points will act as the points of inflection. Now, and also we discussed the standard normal variate, whose density function is 1 by sigma root 1 by root 2 pi e power minus z square by 2, where we obtained this by putting mu is equal to 0, sigma is equal to 1 in the original normal distribution. Sigma is equal to 1, and the curve is like this. And now I'm going to discuss a few important things. That means how we are going to apply this normal or Gaussian distribution in order to calculate some probabilities related to our practical environment. That means in our real time, we may face some situations where we need to calculate or assess some probabilities of events, and in those situations, this Gaussian distribution helps us a lot. For this, we need to know some theoretical background, what is this normal table or Gaussian table, and how this will be helpful us to calculate the probabilities. Okay, first, before going to those things, I'd like to tell you how to use this table. First, let me tell how to use this table, because every time I cannot open the slide while solving the problem. That is why I initially give the inputs how to use this table. Okay, and then I'll explain about the theoretical reasons. So, if you want to see a normal table value, if you want to find a normal table value, A of 1.96. Okay, you are supposed to find a normal table value A of 1.96. Then you have to divide 1.96 into 2 parts by drawing a line after the first decimal number. That means here you have to understand that you have to maintain 2 decimals after point. After a decimal, you have to maintain 2 digits. 2 digits must be maintained after the decimal. And you have to draw a dividing line between the number after the decimal and the second digit. That is first digit and second digit after the decimal. Now, this will be a part and this will be another part. That is 1.9 and comma 6. You can divide like that. Now, you have to search for this 1.9 on your rows. That is, from here onwards, you have to start. From here onwards, you have to start 0 like this. You will 0, 0.1, 0.2, 0.3, and you will find 1.9 here. You have to circulate 1.9. And the second part is 6. You have to search for the second part on the top of that means on the column headings. That is, 6 means 0, 1, 2, 3, 4, 5, 6. So you have to circle this. So 1.9 will be searched in the rows 0, 0.1, 0.2, so on 0.9, 1, 1.1, 1. So on 1.9. Okay, and the third part will be search over the columns 0, 1, 2, 3, 4, 5, 6, and you'll draw a line perpendicularly and parallelly, and you'll find the point of intersection, which is 0.1475. That is the required normal table value. So A of 1.96, that is area under 1.96 in the normal curve, is nothing but 0.475, that is 47.5% area will lie around 1.96 on the normal. Okay, that means you have to go for the intersection of these two numbers, 1.9, so 1.9 and 6 meeting at 0. I'll explain it with one more example. See, I'm going to take another example. I'm going to check uh, 1. That means I'm going to check the area less than 1. Okay, on a normal curve. So first, I already told you that we have to ensure that there are at least two digits of the decimal. So we have to rewrite it as 1.00 because we don't have any decimal or any digits. We have to rewrite it as 1.00. Now we have to draw a dividing line between the first digit of a decimal and the second digit. Now, for the first part is 1.0 and the second part is 0. Now we have to search for 1.0 in the rows, that is 1.0, that is 1, and 0 in the column, that is 0, and both are meeting at 0.34134. That is why this value is 0.34134. Similarly, when you want to look at 0.678, you have to ignore the third decimal. You have to consider only the first two decimals and draw a dividing line 0.6 and 7, and 0.6 will be here, 7 will be here. Okay, and both are meeting at this number, sorry, this number, and this is our table value. Okay, in this way we can look into the table or table values when using normal distribution. Now I'm going to explain the problematic part and formulas and theoretical reasons. Yeah, generally in the real time, in the practical times, we may come across uh, three situations of calculating probabilities. P of India. Suppose we let us take an easy example. The score of India in a one-day match may range between 250 runs to 300 runs. Okay, and second situation, India may score more than 200 runs. And third situation, India may all out less than 150 runs. So in general, in our real time, we have three situations. The first situation is score may range between two numbers and exceeding a number and less than a number. This is between two numbers. This is exceeding a number and less than a number. So while solving the probabilities, we'll use different formulae for different situations. For this case, we'll have different formula. For this case, we'll have different formula. For this case, we'll have a different formula. Let us look into those formulas. Here, pi of z means e power minus z squared by 2. Okay. So, p of a less than or equal to x less than or equal to p is nothing but uh, integral a to b pi of z dz. So this is the formula to calculate a probability such that x lies between a and b. That is a to b pi of z dz. If you want to calculate x greater than or equal to a, then the formula will be integral a to infinity pi of z dz. Okay, where pi of z is nothing but the density function of the standard normal variable. That is, pi of z is the density function of a standard normal. That is why we use this form. and p of x less than or equal to a means they have to write like this: minus infinity to a y of z dz. So these are the different formulae which we apply to calculate three different kinds of probabilities in the real time. That is, marks of a student may vary from 60 to 80. A student may score more than 80 marks. A student may score less than 70 marks. In these three situations we have three different forms. Okay. Now, but it is very difficult to integrate e power minus z square dz. Okay, under any limits, it is very difficult to integrate. The integral never exists. So, how to find those probabilities? Because the integration is not possible. We cannot integrate e power minus z square at all. How to find the values? For that, we have the table called normal table, which I have shown you a few minutes ago. Let me show you. This is the normal table which helps you. These are the various integral values of e power minus z square by 2 under various limits. Under suppose 1 to 2 you will have some answer, 2 to 3 you will have some answer, 0 to 1 you will have some answer. So under different limits the values are approximated and written and formed in this table. Okay, and this table helps you to calculate the probabilities. Okay, now let us come to next part of the formula. So, when you want to calculate a less than or equal to x less than or equal to b, and if a and b are of same sign, then you will apply one kind of formula by using normal tables. Okay, and if the probability you are calculating a less than or equal to x less than or equal to b, and a and b are of same sign, you will use a different kind of formula. Let us look into those formula. If a and b are of same sign, then the formula will be equals to the area under b minus the area under a on the normal curve by applied by confronted by the modulus, that is mod of area less than b minus area less than a on a normal curve. This is the formula we'll use when we want to calculate the probability of x lying between a and b, where a and b are of same sign. Okay, and when a and b are of opposite sign, we will use the formula P of A less than or x less than or equal to B. That is the probability that x lies between A and B, where A and B are of opposite sign. The formula will be area under B plus area under A put together in a modulus. That is mod of area less than B plus area less than B. Okay, so these are the formulas that we are going to use to calculate the probability of x falling between two numbers or two limits. Okay, now when we move to the next case, that is to calculate probability that India will score more than 300 runs in a one-day match. India will score more than 300 runs in a one-day match. Okay, how to deal with this? Again, in this situation, we will consider two cases, that is x greater than or equal to a, where A is positive and A is negative. When A is positive, we'll write the formula as x greater than or equal to A is equal to half minus area under A. When A is negative, we will use the formula that half plus area under A. Okay, so when we are calculating the probability that x will be beyond a number, beyond a limit, there will be two situations. The limit is positive, the limit is negative. When the limit is positive, we'll subtract the area from half, and when the limit is negative, we'll add the area to half. Okay, and the third case, that is p of x less than or equal to a, that is India will be all out less than 200 runs, will not score more than 200 runs. For this situation, we'll just use the complementary formula, that is P of x greater than or equal to A, and hence we can easily calculate. So this is about theoretical background about the formula. Okay, now let us take a problem and let us try to solve it by using this. So here we are having a real-time problem. Let x be the random variable that represents the length of time. It has a mean of 50 minutes and a standard deviation of 15 minutes. We have to find the probability that x is between 50 to 70, and that is probability that x lie between 50 to 70. Let me explain it in more precise way. Here we are considering, we are inspecting the duration taken by workers to complete a task. What is the average duration of the workers to complete a task? So we by checking a sample from the population, we understood that they are taking on an average 50 minutes. They are taking on an average 50 minutes to complete the task. And there might be some marginal differences, which is represented by standard deviation 15 minutes. That means to assemble a computer, the workers are taking 50 minutes on an average. With some workers are taking 15 minutes more, and some workers are finishing 15 minutes less faster. Okay. With these statistics, we'd like to calculate, if a computer is assigned to a worker, what is the probability that he will finish assembling of the computer within 50 to 70 minutes. He will assemble the computer between 50 to 70 minutes of time. He won't consume more than 70 minutes, and he cannot finish the task less than 50 minutes. What is the probability? Okay, let's try to solve this. Okay, from the data, what we have mu is equal to 50. Okay, and we have standard deviation as 15. Okay, now we want to calculate probability that 50 less than or equal to x less than or equal to 70. This is our question. Now we'll use the transformation between z and x, that is z is equal to x minus mu by sigma. You know, z is a standard normal variate and x is a general normal variate. Okay, now by using this, we'll calculate. Let us take x1 is equal to 50 and x2 is equal to 70. Then we will calculate z1 and z2. Z1 is x1 minus mu by sigma, z2 is x2 minus mu by sigma. So this is equal to 50 minus 50 by sigma, and this is equal to 70 minus 50 by sigma. 50 minus 50 means 0. 70 minus 50 by 50, that is 20 by 15, that is 4 by 3, that is 1.33. So Z2 is 1.33. After doing these calculations, we are moving ahead to find the probability. Okay, so we got when x1 is 50, it is transformed to z1 is equal to 0, and x2 70 is transformed to z2 is equal to 1.33. Now our wish is to calculate that the probability of x lying between 50 and 70. That is probability of 0 less than or equal to z less than or equal to 1.33. Now here we observe that 0 and 1.33 both are positive. That is, both are of same sign. Same sign means a of 1.33 minus a of 0. That means area of upper limit minus area of lower limit. That is what formula we have discussed. So both are same sign means areas will be subtracted. Upper limit area minus lower limit area. Luckily, a of 0 is 0 because a of 0 is 0. And a of 1.33, or else let us go to the table and let us check it. So this is the table, and A of 0 means A of 0.00, right? A of 0 means A of 0.00, which is nothing but 0. So this is 0. A of 1.33, you have to divide a line over here. This is 1.3, this is 3. 1.3 lies here, 3 lies here. Both will meet, both will meet at this number 0.40824. That is A of 1.33 is 0.408. So the answer for that problem will be mod of 0.4082 minus 0. That is equal to 0.4082. That means we are saying that there is a chance of 41% approximately that the worker is going to assemble the computer between 50 minutes to 70 minutes. The chance is 41% approximately. So this is how we'll apply normal distribution in order to calculate the probabilities in a real time. Okay, and we'll try to understand it with some more examples. Yeah, let us take more real time example. The mean life electric bulbs manufactured by a firm is 1200 hours. That means a Philips company. You know, Philips is a very popular manufacturer of electric bulbs. Philips company stating that the average lifetime of the bulbs is 1200 hours. 1200 hours. With a standard deviation of 200 hours. Some bulbs may work more 200 hours than 1200, and some bulbs may fade out 200 hours less than the 1200. Okay, that is what they have stated. Now we have purchased 10,000 bulbs. We have taken a sample of 10,000 bulbs of Philips company and we inspected. And in our inspection, we obtained average. The 10,000 bulbs on an average lasted for 1050 hours. What is the probability that our sample 10,000 bulbs lifetime will more than 1050 hours? Okay, and also we have to calculate the bulbs. What percentage of the bulbs will uh, expected to find before 1500 hours of service? Okay, that is P of x less than or equal to 1500. Okay, these are the probabilities we need to calculate. So according to the data, the mean is 1200 hours. The standard deviation is 200 hours. Okay, and in the first bit, we are supposed to calculate the mean lifetime of the sample 10,000 bulbs. Here I am writing the sample size, that is 10,000 bulbs we are inspecting. Okay, the probability that x greater than or equal to 1050, and then we have to find the expected number. Second, we have to calculate P of x less than or equal to 1500, and we have to calculate the suitable expected number of bulbs. So this is the brief structure of the question. So here we are using the formula z is equal to x minus mu by sigma. This is the transformation formula from x scale to z scale. That means we'll transform every normal variate into standard normal variate by using this formula. Okay, it's like changing centimeters into meters, Fahrenheit into Celsius, or liters into milliliters, like that. We are changing the scale from x to z. Now, our first question is P of x greater than or equal to 1200. So let us take x1 is equal to 1200. Then z1 is equal to, okay, z1 is equal to x1 minus mu by sigma. x1 minus mu by sigma. Sorry, here. Sorry. The first bit we have to find is probability of x greater than or equal to 1050 hours. Okay. So here our x1 is 1050. So according to the formula, z1 is equal to x1 minus mu by sigma. Okay, where mu is 1200, sigma is 200. So x1 is 1050 minus 1200 by 200. So automatically the answer is minus 150 by 200, isn't it? And this is minus 0.7. So ultimately we got z1 as minus 0.75. So let us start with the question. X greater than or equal to 1050. This is our target, which is transformed to z, which is equals to minus 0.75. It is like model 2 because greater than or equal to, and this is negative. Negative means we have to add the area to half. Okay, and we know that this function a of z is nothing but 1 by root 2 pi e power minus z square by 2, which is an even function. Even function means minus will be absorbed. So you can write it as 0.75. Okay. And from the table, a of 0.75, okay, that means 0.7 and 5 both are meeting at 0.27. So the answer is 0.5 plus 0.2734, that is approximately 77% of chance. 77% of chance that our sample bulbs will stand for more than 1050 hours. But we are asked to find expected number. Expected number, right? For expected number, we have to multiply the 0.77, the probability with total number of bulbs we brought, that is 10,000 bulbs. 10,000 bulbs means approximately 7,730 or 34 bulbs. Okay, so 7,734 bulbs out of 10,000 bulbs we brought uh, will will glow continuously more than 1050 hours. Okay, similarly we can calculate the second bit, that is p of x less than or equal to 1500. Here x1 is 1500 and hence z1 is equal to x1 minus mu by sigma, that is 1500 minus 1200 by 200, that is 1.5. So p of x less than or equal to 1500 is equal to p of z less than or equal to 1.5, that is equal to 1 minus p z greater than or equal to 1.5. Okay, 1 minus, because this is positive we have to subtract from half a of 1.5, and from the table you can find this value and you can find the answer. Okay, this is the way how we will apply normal distribution to find out the real-time probabilities in various situations. And here we are having another problem. Height of students is normally distributed with mean 165 centimeters and standard deviation 5 centimeters. That means in our IARE college, there are almost studying 5,000 students, we can assume. All the four years BTech as well as MBA and Tech total together, we may have 5,000 students. And we know we have assessed that the average height of our college, 5,000 students, is 165 centimeters. The average height of IRE college students is 165 centimeters, which may vary plus or minus 5 centimeters. That is, the sigma is 5 centimeters. Basic, being knowing that these statistics, we were trying to find the probability of height of the students. What is the probability that if you pick up a student randomly, what is the probability that he will have height more than 177 centimeters? What is the probability that a student who is chosen randomly will have height more than 177 centimeters? And also we are supposed to find if you have picked up a girl, and what is the probability that the height of the girl will be less than 162 centimeters? Okay, now while moving to the calculation details, this is the transformation formula. and our mu is 165 centimeters. IARE average height is 165. The standard deviation is 5 centimeters. Okay, and once we transform 177 to z square from x square to z square, it becomes 2.4, and hence we arrive at step. Okay, that means we have to calculate. You can understand it through a diagram also. This is 2.4. Greater than means we have to calculate this area. We know thus total area is 1, and this entire area is half. Okay, so we have to subtract this area. The total area is half. We have to subtract half, and this area will get this shaded area. That is what we have written here. This area from the table will be, or else by using the formula we can write this is positive. Positive means half minus area. Half minus area. So from the table, the area is 0.4918. So it is very meager probability, 0.8% of chance to find a student more than 177 centimeters height in our college. That's what the statistics says. Okay, and moving to the second bit, when you pick up a girl randomly, what is the probability that she will have less than height of 162 centimeters? So here our x1 is 162, and by using the transformation formula, x1 minus mu by sigma 162 minus 165 by 5, that is minus 3 by 5. Okay, and this is nothing but minus 3 by 5 means approximately 0.67 something, 0.67. Okay, so minus 0. So this is minus 0.67, and we have to calculate x less than 162, that is p of z less than or equal to minus 0.67. So we can write it as 1 minus probability of z greater than or equal to minus 0.67, and we can calculate just as we discussed in the last problem. Okay, and finally, I'd like to conclude the lecture. Finally, I'd like to conclude the lecture with a small problem. Most graduate schools of business require applicants for admission to take graduate management admission council, that is GMAT examination. You know it pretty well. GRE, TOEFL, IELTS. These are very famous examination for BTech students. And similarly, GMAT is a famous examination for MBA graduates. So, scores on the GMAT are normally distributed with a mean of 527 and standard deviation of 1. Under India, GMAT exam is conducted, and on an average, the candidate scored 527 out of 600, most students, and 650 out of 650, and most of range between 112. That means 527 minus 112 to 527 plus 1. Okay, and he clearly mentioned that they are the distribution of marks is like normal distribution. So from the data we observed that mu is 527 and sigma is 1. Now with this we are calculating the transformation, because we want to calculate what we are asked to calculate. What is the probability that an individual will score above 500? That means if you pick up a student randomly, he will score more than 500 marks. That is our target. That is our targeted probability. A student, what is the chance of a student scoring more than 500 marks in the GMAT exam? So for that, here we are transforming from x scale to z scale, x minus mu by sigma, 500 minus 527 by 112, that is minus 0.247. So this is nothing but probability of z greater than minus 0.24. So which can be written as 1 minus p of z, z greater than means it's a model 2 and it is negative. So half plus area of 0.2. Okay, let us go back to the tables. Area of 0.24 from the tables will be, yeah, here. The table gives you area of 0.24. Okay, here you have to draw a line. 0.2 means this number, 4 is this number, both are meeting at this. Okay, so the answer is 0.09. By using that, we can write it as 0. Half plus 0.09, which is 0.59. Okay, 0.094, that is 0.594, that is what written here. Okay, and uh, in the same way, you can also calculate how high must an individual score GMAT in order to score in the highest 5%. To stay in the top 5% toppers, how much minimum marks you should need to get? What is the minimum required marks you have to get in order to stay in the top 5% toppers in the GMAT exam? Okay, so that means you have to find x less than or equal to some a, that is the minimum cutoff. Okay, so that you will stand in the top 5%. That is 5% means 0.05. So here we'll convert this as p of x greater than or equal to a 0.05. That is p of x greater than or equal to a is 0.95. That is because a is positive, because marks means definitely it will be a positive number. So a is a positive, that means half minus area of a is 0.95. So highest 5%, 0.95. So least marks we have to find. So I think this is plus. And then a of a is 0.95 minus 0.5, that is 0.45. If you check for this in the table, okay, check for this table, the equivalent number will be a of 1.645. So in order to stay in the top 5% students, you have to score 1.645 marks cutoff. You have to reach this cutoff, then only you will be stay in the top 5%. Okay, here somewhere we might have misunderstood the minimum cutoff. Okay, this is greater than, sorry, this is greater than, this is greater than, this is minus, and hence will. Okay, so this is the way we'll apply normal distribution or Gaussian distribution to find the real time probabilities. Okay, so with this I'd like to conclude today's lecture, and in the next lecture we'll meet with some more problems and moment generating function, cumulant generating function of Gaussian distribution, along with some more interesting examples on Gaussian distribution. Thanks for your patience listening. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.